Hello everyone. Today I would like to present a paper co-authored with Dennis Lehmkuhl. Before doing so, I would like to briefly acknowledge two research groups as part of which we have conducted this research. The first one is this research unit, consisting of physicists, historians of physics, philosophers of physics, and sociologists of physics, and together we work on these 6 related projects. The second group is the new Lichtenberg Group for History and Philosophy of Physics at the University of Bonn, and you can follow us on social media. What I would like to do today is push back against a certain standard story that started with Democritus and was revived by Newton and has reigned supreme ever since. And the story is the claim that there's a strict conceptual dichotomy between matter and space-time. In other words, everything in our universe, or even in possible universes, is supposed to be either space-time or matter, but never neither and never both. And sometimes this standard story is backed up by the container metaphor, well known, the idea that space or space-time is a container which contains matter. Matter is the stuff that is contained. Everything is either container or contained, but cannot be both and cannot be neither. And what goes hand in hand with this story is the idea that there isn't one space of theories, but 2 separate spaces of theories. One space of space-time theories, where presumably general relativity lives, and another space of matter theories, where, for instance, the standard model of particle physics lives. So what we want to do is push back a bit against this standard story. So in other words, we are questioning the tenability of a strict conceptual distinction between matter and space-time. This has been questioned already in contexts such as general relativity in other contexts, but there's far from consensus in those contexts. So what we would like to do is look at it from a novel angle, where we think the issue is particularly urgent, namely the more narrow distinction between dark matter on the one hand and modified gravity on the other hand. And since the theories we'll be looking at, for those gravity and space-time are 2 sides of the same coin, we can take modified gravity to be synonymous with modified space-time. So we're looking at narrow distinction between dark matter and modified space-time, and see if that has consequences for the broader distinction between matter and space-time. And we've written 2 companion papers on this issue, and today I would like to focus on the second. First, I need to say a bit more about the debate between dark matter and modified gravity. Turns out if you take standard matter, so luminous matter, and standard gravity, Einsteinian or Newtonian gravity, and if you use those to predict certain effects like the behavior of galaxies or structure formation, you will predict an effect that's weaker than what you observe. And this happens at the level of galaxies, the level of galaxy clusters, and also at the smallest level of galaxies. So if luminous matter plus gravity gives you an effect that's too weak, then there are 2 options. Either you need to add more matter, but we don't see it, so it must be dark matter, or we need to enhance, to boost, to modify gravity. So those are the 2 options, dark matter or modified gravity. And typically dark matter theories do well at the larger scales, so the scale of cosmology and galaxy clusters, and typically modifications of gravity do well at the scale of individual galaxies. So there is kind of a stalemate between these 2 camps, and in response to that stalemate, there is this recent trend of hybrid theories, which try to be the best of both worlds by postulating some entity or mechanism that acts as dark matter on large scales and modified gravity on smaller scales. And today we'll be looking in particular into a case study called Superfluid dark matter theory, which has received a lot of traction within the physics community. And for all these theories, you can ask of the new entity or the mechanism that they postulate whether that entity is matter, dark matter, or space-time, modification of space-time, or both, or neither. Of course, if you want to do that, we first need to discuss what it is to be matter, dark matter, and what it is to be space-time or modification of space-time. So let's start with matter. the weakest criterion you could come up with is, say, to be matter is dynamical, to change, to not be static. This is already enough to distinguish Newtonian space, which is immutable, from Newtonian point particles, which move around. Nevertheless, often people like to flesh up or to add more flesh to the concept of matter. Sometimes it's insisted that there's some action-reaction principle. So to be matter is to react when acted upon. Some authors go further and say one needs to be able to associate a notion of exchangeable energy with this action-reaction. The strongest criterion you could come up with is to insist that part of this energy is due to rest mass of the object under consideration. So in other words, to say the object carries mass, is massive, has mass. Right, so to be matter is to be massive. That's the strongest possible criterion. Okay, that's matter. What about space-time? Well, space-time is usually represented by some mathematical structure from differential geometry, a manifold with a connection and or a magnetic field and or a formal structure. This by itself is not enough, because what if you have several such structures in your theory? Or what if this structure is used to present configuration space or some other space rather than the physical space that we're after? So what you want on top of that is to make sure that test particles and light rays follow the GD6 of one of the metrics connections, and then that's good reason to believe that that metric or connection is the physical space, the one that's being experienced by matter in the form of test particles and light rays. And you also want to check that the metric or connection couples in the right way to matter, such that locally rods and clocks behave the way you would expect from special relativity. If that's the case, then these criteria together form sufficient reason to call something space-time. Okay, so now we have criteria for matter and for space-time, and we want to ask this new thing postulated by superfluid dark matter theory: is it matter or space-time or both or neither? So first we need to say a bit more about what superfluid dark matter theory is supposed to be. And in response to the stalemate between dark matter and modified gravity, Biasiani and Cooley have developed a hybrid theory that's supposed to be the best of both worlds. And the wish is to find a single new entity for which there's a natural reason why on large scales it behaves like dark matter, but on galactic scales, so the smaller scales, it behaves like a modification of gravity. And Biasiani and Cooley suggest that the solution is something called superfluid dark matter, which is a massive field which normally acts like dark matter particles, but in galaxy it condenses to a superfluid phase. That means you get superfluid sound waves, and since these are massless phonons, they can mediate a long-range force, and if you choose the right kind of superfluid, then you can get the modification of gravity that is required by the data. All right, so the idea is at large scales you have this massive particle which behaves like dark matter, and at smaller scales it gets superfluid phonons which mediate a modification of gravity. So, okay, so then the question is, this new field, what is it exactly? And as I just said, kind of both. It's massive, so that means it satisfies the strongest criterion for being matter, so in this case dark matter, but also, at least in the superfluid regime in galaxies, it turns out that test particles and light rays and rods and clocks follow not the standard Einstein metric, but a new metric which is defined from the Einstein metric plus this modification by the superfluid phonons. That's the one that's being experienced by test particles, light rays, rods, and clocks. So this new thing counts also in galaxies as a modification of gravity, of space-time. Right, so it's as much dark matter as possibly could be, and as much of a modification of space-time as anything could be. This was the result of the first paper, the prequel paper, but that leaves open some interpretational questions. Like, does this mean it's like really dark matter and mimics modification of gravity, or is it both? Or does this have consequences for the distinction between dark matter and modified gravity, and maybe between space-time and matter? So what we do in the paper that's the focus of today is we try to go beyond this and say, okay, if this is the case for theories such as superfluid dark matter theory, how should we interpret them and what are the consequences for the dichotomies? Here's one option. Let me start with an analogy. So some things are 100% human, other things are 100% such as Zeus, 100% God. Then we have demigods such as Heracles. And then according to the consubstantiality thesis within Christian theology, Jesus is 100% human and also 100% God. And that's all there is to say. This doesn't in any way mean that we can't talk about humans as humans anymore or about God as God anymore. The fact that there's something which is both fully doesn't change anything. So by analogy, you could say, or the minimal interpretation of superfluid dark matter theory is that this novel field is 100% dark matter, 100% the modification of space-time. These roles are on a par, and this doesn't have any further consequences. So this leaves the dichotomy between dark matter and modified space-time, the conceptual dichotomy, unaffected. It remains coherent, applicable, objective, and useful. And there's a second group of possible interpretations which you might try to apply to this theory. It says, well, maybe you can say a bit more. Maybe they're not on a par. Maybe it's the case that this theory, this new field, is fundamentally dark matter and only merely emergently modified gravity, or the other way around. Or maybe fundamentally it's something different altogether, and only at the emergent level does it look like dark matter, modified gravity. Or maybe it's the case that at the fundamental level it's both dark matter and modified gravity. Right, so this gives us 4 more options. And then there is a third category of possible interpretations, which we might call the breakdown interpretations, and they say, well, this new field, which seems to satisfy both roles, conceptual roles fully, has implications for the conceptual distinction between dark matter and modified spacetime. The strongest of such interpretations would claim that this theory reveals that actually the distinction between dark matter and modified spacetime is incoherent altogether. It's kind of made, it's meaningless. A slightly weaker interpretation would be like, no, you can make the distinction, it's not relevant in this theory. It's not the right vocabulary for this theory. It might have been for Newtonian physics, special relativity, whatever, but those are not the right categories for a theory like this, a hybrid theory, which is not purely dark matter or purely modified gravity. Weaker still, you could say, okay, these concepts are applicable, but it's not objective which one applies. It's just a matter of convention whether you call it dark matter or modified gravity. And the weakest of all these interpretations says, okay, the distinction remains coherent and applicable and even objective, so not conventional. However, it's not clear that we have any use for it anymore. It might have been useful in theories or for objects which are purely matter, purely space-time, but now we have this weird hybrid object. It's not clear that these categories, that we get anything out of them, so we might as well, it's more conceptually parsimonious to get rid of them. Okay, so altogether this gives us an interpretational chart of at least 9 possible interpretations for theories, for hybrid theories, and most of the paper, the second paper, is about spelling out in detail which of these interpretations fit superfluid dark matter theory and which don't. And the conclusion we reach is that 5 of them are ruled out and 4 of them are still viable. So this is one of the main results of the paper. However, perhaps it's not the most important result. For different hybrid theories, different interpretations might be more suitable, and maybe there's even theories which have nothing to do with dark matter modified gravity which fit different interpretations. So perhaps the main result of this paper is that we've provided a chart of interpretations that we can use to help understand, to navigate, to cartograph the single space of theories, to help us figure out how all these theories in the single space of theories relate and how we should interpret them. And this gives us a menu, so to speak. Now, I said on purpose single space of theories rather than 2 spaces of theories, because I think we should have realized at this point that part of the standard story that there are 2 separate spaces of theories is not tenable. superfluid dark matter theory has helped us realize that hybrid objects, such as the new field postulated by Berziani and Cooley, this doesn't fit into just the pure space of dark matter theory, of matter theories, or the space of pure space-time theories. It falls somewhere in between, so to speak. And even though this conclusion is highlighted by superfluid dark matter theory, we could have already realized it earlier, because if you look at our criteria for matter and for space-time, whether something satisfies the matter criteria, whether you have mass or energy, doesn't in any way say anything about whether that object is or is not going to also be space-time. Similarly, if an object is space-time or not, that leaves open whether it's also matter or not. These sets of criteria are independent, so logically speaking, there are 4 options. You could satisfy both of them, or neither of them, or one but not the other. So there's no reason to expect probably why the space of theories of logical possibilities factors into a space of pure space-time theories and pure matter theories, and that's it. No, you would just expect a single space of theories, and maybe some region of it might be pure matter theories, and another region might be pure space-time theories. But how large these regions are, that's we need to figure that out. So I guess that's one of the main upshots of the paper. There's 2 other consequences. One is for the substantialism relationalism debate. There, the 2 camps, the only thing the 2 camps agree on is that there's a conceptual distinction between space-time and matter, and then they go on to disagree about how these relate to each other in terms of relative fundamentality. Of course, under breakdown interpretations, that debate becomes moot, because that distinction just breaks down. And even on the consubstantiality interpretation, where it said that these roles are on a par, this debate becomes moot. So several of these interpretations have severe consequences for the substantialism relationalism debate. Moreover, it happens to be the case that the dark matter modified gravity communities are somewhat infamous for hostility. They tend to think that for them to be right, the other camp has to be wrong. I think one upshot of looking at such hybrid theories is that they seem to be the best of both worlds. If they are the correct description of nature, then both camps win, and winning doesn't have to mean that the other camp lose. It basically means we're all on the same team, which is great news. Okay, so those are the upshots of the paper. The main thing we have done is provided a chart of interpretations for theories that aren't obviously just matter or just space-time, and that can be used to help understand such theories and navigate the space of theories. Where to go from here? One further question you might ask is how we could modify this case study or other case studies to make them more or less dark matter-y or modified gravity-like, in order to better understand these concepts. And we might ask whether it's the norm or the exception in space of theories that objects are pure or hybrid, whether they fall into exactly one category or not. And maybe the difference between consubstantiality interpretation and breakdown interpretations is most interesting at the level of the space of theories, because if Jesus in the Bible is rare, so the fact that this is one thing which instantiates the category of human and God, that's not really going to cause any problems for these categories. But on the other hand, almost there will be many Jesuses and hardly any gods or humans, then maybe that distinction is less useful. Similarly, if it turns out that much of the space of theories consists of hybrid theories, that would be very much in the spirit of the breakdown categories interpretations. We don't really need that distinction anymore. If on the other hand, hybrid theories are very rare, then in practice, most theories fall neatly into one or the other categories. So that would give reason to hold on to the distinction. And a further sense in which we might move on, might do further research, is not look only at dark matter modified gravity theories, but ask these similar interpretational questions in a whole list of different other case studies, which you can find here on the slide. Thank you very much for